Our Tennessee state standard today is to solve linear equations with rational number coefficients, including equations whose solutions require expanding expressions using the distributive property and collecting like terms. Your lesson objective that you need to pause the video and write down. I am learning to solve one-step addition and subtraction equations using the subtraction and addition properties of equality. All right, so we're going to sing again. You need to practice this so you'll be ready to sing with me. Still goes to the tune of If You're Happy and You Know It. If you want to solve equations, here is how. Read them with their operations, do it now. Then undo them every time by directions in this rhyme. Do the opposite, that's what the rules allow. Okay, practice that. We've got another verse. If you read minus, then to solve it, you must add. If you say plus, you must subtract or you'll be sad. Multiply will get undone by dividing everyone, and divide gets multiplied or answers bad. All right, I think there's one more verse. I know y'all are going to do so good singing this tomorrow with me. Oh, equations must stay balanced to be true. What you do to one side, you must do to two. And to solve for the unknown, you must get it all alone, using every single trick you know to do. Look forward to singing that with y'all tomorrow. All right, so today I'm going to introduce you to algebra tiles. And green, the green one is positive. Red, remember, red is blood, red is bad, red is always negative. So the green rectangle is X, represents X. The yellow square represents a 1. The red rectangle represents negative X, and the red square represents negative 1. So to model X plus 4 equals 7, and this is not on your notes, so you can just follow along. This is X, then I would need to add 4 ones, so that says X plus 4. And then on the other side of the equation, I would have 7. This takes a while. Apologize. Whoops, missed it. All right, so I want to get X by itself. That means I want just the green rectangle to remain. So what do I need to do? How about if I take away, just get rid of these. That leaves me with the green rectangle all by itself. But if I take away 4 squares or ones from the left side of the equation, I have to do the same thing on the right side of the equation. So now we have X equals 3. Now, I'm sure you could have looked at that and said, Ms. Sparks, I already know 3 plus 4 equals 7, so I already know that. But we're going to show our work, and I will show you in just a moment 3 different ways that you can show your work. So that gives us X equals 3. All right, let's do this. X plus 1 equals 4. Well, we drag out the X and the 1. And then on the other side of the equation, we drag out 4 squares. What do? Same thing. We want the X or the green rectangle by itself. I get rid of 1 on the left side, so I have to get rid of 1 on the right side. So X equals 3. Most of you can say, I already know 3 plus 1 equals 4. All right, so if you're okay with this, I'm not going to drag out. I'm actually going to draw now. So X plus 3 equals 7. Here's my X. Now I'm going to put a plus there. because if I'm drawing with a pencil, I can't change colors. So x plus 3, so square, positive square, positive square. So that says x plus 3. And then we're going to do 7 positive squares over here. One, two, three, four, five, six, one more, 7. So I want the x by itself. So I'm going to get rid of these 3, and I'm just going to mark through them with big X's. They're gone. But if I X out 3 on that side, I have to X out 3 on this side, which gives me x equals 4. You already knew 4 plus 3 equals 7. And finally, let's draw this. X plus 4 equals 6, so we do the rectangle and then 4 squares. So that says x plus 4. And this says 1, 2, 3, 4, 5, 6. So x plus 4 equals 6. Let's get rid of the 4. And if I get rid of 4 on that side, I have to get rid of 4 on this side. So x equals 2. So now let's see. Explain how to solve the following equation without using algebra tiles. X plus 3 equals 8. Most of you already know that the answer is 5. How do you know that? I want you to be able to explain that to me tomorrow. All right, the subtraction property of equality says that if you subtract the same number from each side of an equation, the two sides remain equal. Now, I started with a number, 7 equals 7, so that you could see that 7 minus 3 is the same as 7 minus 3. It's still equal to 4. It's still a balanced equation because 4 equals 4. So now that you can see x plus 4, we don't know what x is at this point in time, but x plus 4 equals 6. So to be able to determine x, to get it by itself, I can subtract 4 from each side, which gives me x equals 2. All right, here are your methods of solving. Method 1 is vertical. And I like to box in my terms. Always draw the line in front of the sign. So this is 2 terms. I have an x, and you can draw that. Remember, as the rectangle. And then you can draw 5 squares here. So x plus 5 equals 3. Now, this is a little bit harder to take away here, and we'll get into zero pairs in just a minute. But if you wanted to draw the equation, x plus 5 equals 3. There it is. But I know that I want this x term by itself. So I need to do the opposite of the other box. The other box is plus 5. So to get rid of that, I subtract 5. What I do to one side of the equation, I must do to the other side of the equation, which cancels out because 5 minus 5 is 0, leaving me with x equals -2. That's the vertical method. The horizontal method, you're doing the same thing, you're just doing it horizontally. X plus 5 minus 5 equals 3 minus 5. X equals -2. And finally, cross the bridge method, so that when you take this term, positive 5, across the bridge, you change the sign, so it becomes x equals 3 minus 5. So x is -2. Either method. Does not matter to me which method you use. You choose the method that makes more sense to you. I usually defer to method 1 because it's the way I learned, but if I'm in a hurry, I use method 3. All right, so once you've solved an equation, you need to check it. So you're going to replace the x with -2 in the original equation. So remember, x plus 5 equals 3. We're going to put this in for x and say -2 plus 5 equals 3. Is that true? If it is, you can check it because you just know by checking it that you've got the right answer. All right, so here's some more examples. I'm going to box in my terms, draw the line in front of the sign. So I want to do the opposite of plus 6. I'm going to subtract 6 from both sides. That leaves me with a equals 2 minus 6 is -4. Let's do this one since I'm on this side of the board. So, So some of you might like to see this a little bit differently. If it makes more sense to you to change sides, you can rewrite this equation as m plus 4 equals 5. You can swap sides of the equation like that. All right, so I need the n by itself, so I'm going to subtract 4 from both sides, which gives me n equals 1. 1 plus 4 equals 5. I forgot to check this top one, so let's see. -4 plus 6 equals 2. All right, and finally, we want to get the y by itself, so we have to do the opposite of plus 3, which means subtract 3. Put equals there. So we have y equals -8 plus -3 is -11. And if we plug that back in, -11 plus 3 equals -8. So you may have to pause the video and write those down. All right, inverse operations are operations that undo each other. Addition and subtraction are inverse operations. Multiplication and division, which we will look at in our next lesson, are also operations that undo each other, or inverse operations. All right, so now we're going to subtract. So if I want to drag out x minus 4 equals -3, here's an x, but I can't use this because really I'm saying x plus -4. So I'm going to have to use these. 1, 2, 3, 4. That says x minus 4 equals -3. Now, I could take away a negative, but remember, what's minus negative really mean? It means add. So can I add 4? And if I add 4 to that side, I need to add 4 to this side. Now what we have created here, a -1, and a +1 is called a zero pair. If you put them together, they cancel each other out, which gives me x by itself. These cancel out, which gives me x equals 1. All right, if we want to do x minus 1 equals 3, x minus 1 equals +3. Well, I'm going to add 1 here, so if I add 1 here, to cancel that out, I also have to add 1 on this side. Positive and negative cancel out. That leaves me with x equals 4. And if I wanted to check that, 4 minus 1 equals 3. All right, I'm not going to draw this next one. So x minus 3 equals -5. Should we draw it? Yeah, let's draw it. X minus 3, so 3 negatives, equals -5. Oh, I did that wrong. It's a negative. All right, so then I can add 3 positive to cancel out my negatives and get my x by itself. But when I add 3 positives on that side, I need to add 3 positives on this side, which gives me x equals -2. -2 minus 3 equals -5. And last but not least, I think you all know this. This would be x minus 4 equals 0. We would have to add 4 positive to both sides, which would give us x equals 4. So I want you to think about how to solve the following equation without using algebra tiles. And the equation is x minus 3 equals 2. Without drawing pictures or anything, what do you need to do? I think you already know that the answer is 5 because 5 minus 3 equals 2. How did you get that answer? All right, the addition property of equality says if you add the same number to each side of an equation, the two sides remain equal. So you can see if we start off with 7 and we add 3 to both sides, we end up with 10. Equation is still balanced. The same way, if we have x minus 5 equals 6, we can, because we want the x by itself, we can add 5 to each side. -5 plus 5 cancels out, leaving us with x equals 6 plus 5 is 11. All right. I like to box in my terms. I need to get rid of -8. The opposite of -8 is +8. So I'm going to add 8 to each side. That gives me x equals -3 plus 8 is 5. Once again, you can rewrite this as p minus 12 equals 7. I need to do the opposite of minus 12, so I'm going to add 12, which gives me p equals 19. 19 minus 12 is 7. 5 minus 8 is -3. We want to add 4 to both sides. So b equals -6. -6 minus 4 equals -10. All right, a real world example. Two angles are supplementary if the sum is an addition, the answer to an addition problem. If the sum of their measures is 180, the two angles shown below are supplementary. Write and solve an equation to find the measure of angle x. So we know that it's a sum. We know that we're looking for x, and that if we add 94, our answer will be 180. Box in my terms, I'm going to subtract 94, which leaves me with x on the left side. This would be 7, this would be 10, so 10 minus 4 is 6, and 17 minus 9 is 8. So x equals 86 degrees, and I believe if you add 86 and 94, you will find that that gives you 180 degrees. And that's the end of our lesson. I will see you tomorrow.